All right, my name's Chris. I was mentored by Aly Sivji, and this is implementing Python at an AmeriCorps nonprofit. I'm an analyst at City Year, which is an educational nonprofit that believes in equal access to quality education. Every year we place thousands of AmeriCorps members into 29 city locations to tutor and mentor students that are more likely to drop out. So I wanted to implement Python in this environment because not many cities have an analyst team, and I thought that we could multiply our development if we build it right across the cities. So what I was able to do with Python at work is improve our data intake from the field, our data flow to reporting. I did some analysis, and I built a web app to serve a machine learning tool. We store all of our data in Salesforce. So my first revelation in this mentorship was just to use the Salesforce API through Python scripts to automate all of the manual processes we had been doing. So without Python, that looks like a lot of Excel spreadsheets submitted to Salesforce through a user interface, and sometimes clicking through that interface, sometimes hundreds of times, depending on what population of people you were trying to get data in for. So I was able to automate nearly all of that. In some cases, I don't have access to edit fields, and I still have to click through the browser to make those effects. But I was able to use Selenium WebDriver to automate all of that as well, although it's a little buggy. In data flow to reporting, I use a ton of Excel and Power BI, and those are fantastic tools that enable continual access to data that's real time. But doing that through Python allows you to have total control over the file structure and do things like automated PDF distribution. So there's a big gap in my organization between technical access and the paper tracking that happens. So I did some PDF distributions to make sure that everybody had data in hand every week where they could track the services they're providing. I also got the data into Jupyter Notebooks. So I developed a system with Pandas, Seaborn, NumPy, and PyMC3 to investigate a couple of themes. Namely, or broadly, these themes are: what are the attributes of tutors in schools that relate to student success and all the targets that we have, and tutor satisfaction as well? Can we better model program implementation to set expectations and inform actionable intervention? For example, here's a visual showing tutors' student performance versus tutoring quality. Each dot in this visual is a tutor, and on the y-axis is that tutor's student performance aggregated as one data point, and then on the x-axis is tutoring quality as observed by our coaching staff. You can see the correlations are not very strong, but when you split it out by coach, some of the correlations do start to emerge. So keep in mind, this is only half a year's data. Chicago Public Schools school year ends tomorrow, and with a full year context, I think I'll be able to have more valid results and stronger correlations, and also be able to go back into prior year data to pull out the pieces that might add greater validity from prior years. Finally, like I said, a lot of our data have a manual component. However, next year we're going to have a data sharing agreement with Chicago Public Schools that should really clean up our database. The last thing I did in my mentorship was build a Django web app to serve a machine learning tool. So in the last year and a half, I wrote a placement algorithm using R that places our tutors into schools based on diversity, short commute times, and language speaking ability. This year, our tutors are traveling on average 90 hours less than they did last year over the entire course of the program, and only 10% of our tutors are traveling more than 60 minutes in one way. However, this tool is still pretty technical, and it's difficult to implement in all those cities that don't have analytics teams. So I built a web app in Django, packaged into Docker, and put into production on Microsoft Azure. This is what that looks like in effect. The user uploads a spreadsheet of school data, a spreadsheet of tutor data from a survey in onboarding, sets a couple of parameters for the algorithm, like whether they want to calculate commute time, and then it runs it. It usually takes like 2 hours, depending on how many iterations. But there you go. One thing that I still need to do is build out a dashboard that kind of proves that these are good placements, but that exists in a different program at the moment. I learned in this mentorship that there are tons of potential to use Python in non-Pythonic spaces, and I'm really excited to figure out what else I can do. So thank you to ChiPy and to my mentor Aly for all the time you devoted.